Visible ang slide?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Yes, sir.
Okay, thank you, thank you. Audible maka ko sa inyo ah.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Just to make sure lang, kaya kasi hindi na sa ito magbungog ka ron. Okay, we're done discussing about the, ano, the direct current and the alternating current.
Mana, sir.
Mana na,
Manatalanin mo?
sir.
Okay, so let's move on to the next
Mana na, sir.
next lesson. Our next lesson has something to do with the direct current and alternating current as well. But we'll go beyond the definition of those two. Okay, so this is the illustration of how we represent the direct current and the alternating current. So try to look at this picture. Sorry. Kita pa siya. Okay, so this is how we illustrate the direct current, the alternating current. Okay, try to look at this picture. So the name itself, okay, represents this illustration. So now let's talk about current. Since we keep on talking about direct and alternating currents, let's talk about current. Current is the flow of electrons through a conductor. And you know already what's the conductor, di ba, class? Okay, conductor are what? Are or the conductor allows the electrons or the electric current to flow, you know, into a specific medium. So the current is measured in ampere. Actually, we represent current with the letter I nga capital. Okay, we will be dealing that one later as we try to do some calculations when it comes to basic electricity. So the let's say the unit of the current is an ampere. Okay, and we measure the current by using the ammeter. So if nata sa laboratory ka ron, maybe I can present to you the illustration of the ammeter. No? So if you have time, you can actually just Google that one. Okay, try to look for the picture of what is uh, the sample of an ammeter. Now, the electric current that flows is in this. Okay, try to look at this picture, class. Okay, this is how the electron current flow. So from the negative to positive flow, okay, if you talk about electric current flow, we need to consider the fact that electron is a negative type particle. Yes, negatively charged particle. So if the current is composed of electron, it's very visible here that that uh, majority of the charges that will flow in the wire, for example, are negatively charged particles. In the conventional current flow, if you talk about conventional, no, there's an alternate na cycle na kahitabo. And then you can actually see in this picture, okay? So, when we talk about electron current flow, so namatay gitawag na kuan. For example, we have the direct current here. So direct current man good, kakuan siya no, isa lang iyahang path, isa lang iyahang direction. So from negative to positive, and so on and so forth. For the conventional current, as you can see, okay, it's positive to negative flow. So majority of the charges that flows is made up of positive particles. Okay, so sometimes uh, the more number of positive that flows against the negative, the more siya ka-insulate. Okay, the more siya what we call this one, the more siya it prevents, okay, the majority of the electron particles to flow through the wire. Okay, that's the reason why natin kitawag insulator. Because sometimes majority of the numbers of those positive particles are let's say uh, it stops the flow of the negative charges or the electrons. That's the reason why stop siya. Okay. Now, if we have this, if we go back to dito sa basic sa basic figure about the types of circuits. Natin gitawag nga series and parallel circuits. Okay. You've noticed there na sa circuit na to, okay, either it's a parallel or a series circuit, natin gitawag nga voltage. Okay, what is a voltage? Okay, so the voltage is the pressure or the force that pushes current through a conductor. In short, this is where those charges are coming from. Okay, either positive or negative na. Ito nakaka-compose ang kitawag na ito nga kanang voltage. So, unsay source of voltage they sir? It depends on what machines ang gigamit. For example, if we have an example of a solar panel here, the solar panel, ang solar panel dani na siya tawag na storage. No? The storage there has what we call voltage. So the voltage is measured in volts. So uh, capital V, no? It's the same as the kana iyang kwan, ang iyang, even ang iyang symbol sa voltage. And then can be measured with or without the current flow. Okay? Because the voltage here is just the storage of those charges kwan, that that the machine needs, or let's say even the circuits needs. Okay? Because di ka makatawag na ay flow sa circuit ya kung wala kay gitawag na voltage, kung wala kay gitawag na storage. Okay? So it is measured with the use of the voltmeter, and then the potential difference is in between 2 points. So what are those 2 points that we're talking about? We have here the negative and the positive points. Okay? So a battery or a potential, let's say a PV, okay, source provides a DC power source. Okay? If we have a power voltage here, a PV, a battery or a power voltage source provides this direct current power sources. Natin kitawag ng mga resistance. Okay? The resistance here are what we call the stopper. Okay? They're the one that, let's say, formulates the actual kind of itong flow of the current. Either it allows or not. Okay? Depende na siya kung unsay pwede unsay ka na magamit sa resistance. Okay? So by the word of resist, it means to stop or to allow. Okay? Now, a rotating generator could produce an alternating current. Okay? That's why some supplies can convert AC to DC or DC to AC. Again, it depends on the machine na gigamit. So for example, no, most of the factories or electrical companies, whether unsay sources ang gigamit, okay, they're actually having this process. Okay? Yeah, sometimes uh, from the storage, from the company itself, from the factory itself, no, they will direct those current or those power sources dito sa mga wires, okay, sa mga wirings. So imagine a company of electricity, and then uh, they provide check power all throughout the city. So either you're actually observing a direct current event or an alternating current event. Okay, but the understanding about the voltage is that it is the source, or it controls the source of what we call electricity. The resistance is the opposition to current flow. Okay, so but it opposed, again, it allows or not the current to flow. It depends on what kind of materials are we using. Are we using the switch? Are we using the outlet? Okay, or blanca? Okay, so resistance is represented by a symbol of capital R, and it has a unit of ohms. Okay, so it is measured using the ohmmeter. Again, if you have time, you can search the actual picture of the device, what we call ohmmeter. So later we'll be discussing the use of the resistance, the relationship of the resistance, the current, and the voltage. Okay, so power. Okay, I think you know already what's the meaning of power, class, because the power is the rate of doing work. Or sometimes, since we have discussed the difference between the machine and then the human power, if we are talking about the machine, we're talking about the energy consumption. Either we are talking about the amount, the time that was the time where the power was used, okay, or the actual person who is using the power to actually do some work. Okay, so power, obviously, it is measured, or it has a unit of watts, and then it also measures the rate at which energy is used in the circuit. So it's the same thing. Now, let's talk about some practical circuits. A practical circuit contains four following characteristics. Okay, first, it has a load. Dili load nga kanang load yun nga sa kuana. Load means a storage. Okay, a load consumes power. Okay, kabantay mo lang mga kuana to. Kabantay mo na ng mga uh, batteries, no? For example, sa cellphones na to karon. Sa cellphones na to karon, the mega ampere per hour of the battery that we have, especially sa tong phone, are increasing. Okay, the point of increasing the kwan, uh, the consumable power or the voltage in every phone's battery is for us to kwan is naka-kwan siya, no, dapat naka-align siya or at least no compatible siya sa device kung asa nakapansak ang battery. For example, if the phone is a mobile gaming phone, of course you have to uh, to use a very large amount of battery, a load of power for that device to consume that power in a, let's say, in a guaranteed way. Okay, dili bitaw siya sayang bitaw sa mga tao or sa person nga nagamit na nga device because that person know na kanang siyang device nga gamit for mobile phone is actually for mobile kanang gaming. Okay, a switch to control load for safety. So those are what we call again, natin kitawag ng switch, natin kitawag ng plangka. Okay, it's a switch that controls the load for safety. We also have the power supply. The best example for the example that we have here is a photovoltaic source to produce uh, a potential voltage power. Okay, so a photovoltaic source is somewhat like, for example, this solar panel. No, the source of the light is the source of the power supply, and then we have a path of electrons to flow. This is what we call wire. So this is how we define and understand the circuit. But actually, we have to focus our attention on those two different circuits that we have. Again, we have two types of circuits. The uh, we have the series circuit and the parallel circuit. Okay, it's the same thing with the direct current and the alternating current. Okay, those are the uses of those current and sources. Now, let's talk about ohms. So, sir, ngano ato magi-discuss ang kailangan nato i-discuss ang voltage, ang current ug ang resistance because natin gitawag ka calculations, di ba? Dili man kompleto ang physics wala calculations class. So if we define Ohm's law, asa gani nga unit ng ohms gani? If you can recall, asa gani nga unit ng ohms? Is it voltage, current, or resistance?
Resistance, sir.
Okay, it's resistance. Thank you. The ohms is the unit for resistance. So in ohms law, actually we're looking for we're looking for the unit of the resistance. We're looking for the amount of the resistance. So it requires 1 volt to push 1 ampere of current through a 1 ohm of resistance in a direct current circuit. It means that it is proportion to how large is the voltage, how the current flows, and then how large the resistance. Okay, so how can we calculate or how can we represent the Ohm's law in a mathematical representation? Actually, we have here different formulas to calculate different portion of the circuit. We have here to calculate the voltage, we have V is equals to the current times the resistance. If we are looking for the current, we have to do some uh, derivation. So by deriving, we get the current by just dividing both sides by R or resistance. So we have current or I is equals to the voltage divided by the resistance. And then to calculate the resistance where the unit of ohms is located, okay, or is measurable, so we have R is equals to V divided by I, okay, or voltage divided by the current. So for the voltage, we have the unit of volts. For the current, we have the unit of ampere. And for the resistance, we have the unit of ohms. So for us to elaborate more about the use of the ohms laws, we have here a sample problem. Okay, we have a sample numbers. Okay, a sample given. If we have a voltage of a 12 volts and then a resistance of 3 ohms, then we're looking for the current. So for us to see or to find out the unit or the amount of current that flows between the 12 voltage and the 3 ohms of resistance, we will now use the formula for the current. We have I is equals to V divided by R. So just substitute the given values. We have V, which is 12 volts, divided by 3 ohms for the resistance. So we have an answer of 4 amperes. Okay. Okay. Let's identify the equation by this. Okay. The chart is divided to 4 sections with formulas that can be utilized. We have the power. Actually, you know already to how to calculate the power class because we have uh, we're done discussing that one on our general physics one, diba? So we have many ways to calculate the power, but actually we don't. The formula that we had last time is just was focusing on the human power, I guess. No? And then we also have there how to calculate the power supply. Okay, so just try to do some recalling about our discussion sa power. Okay, so we have an example of how we represent or how to explain this chart. Now, if the power is 180 watts and the voltage is 40 volts, then the formula we need to calculate the current is okay. So try to look at this formula here. Okay, so what we're looking for is the current. If we're looking for the current, so if we go back on the formula of calculating the current, so we have I is equals to V divided by R, no? And then here in this formula, we have I is equals to the power divided by the energy. Okay? So how are we going to calculate this one? So the simple way, okay? So okay, try to look one, try to look at this chart. Okay? The E here class is the voltage class ha. Okay? Since the voltage is the energy source man siya, so it's represented by so it's the same thing. Uh, Same goes with the power. Okay, so we're looking for the current. So we have 180 watts divided by 40 is 4.5 ampere. Okay, so what are the formulas that we can use later if if we will be calculating the power? So we have E squared divided by R. We have P is equals to E times I or V times I. We also have here P is equals to I squared times R. If we will be looking for the resistance, we can use actually the following. We have here the voltage divided by the current. We also have here the power divided by the current. And we also have here the voltage in square divided by the power. For the current, we can actually use this formula. The square root of the power is divided by the resistance. And we also have here the power is divided by the volts. And then we have I is equals to the volts divided by the resistance. If we'll be looking for the voltage, we have power divided by the current or I, or voltage is equals to the current times the resistance, or voltage is equals to the square root of the power times the resistance. Okay, so just just try to kuha na lang siguro. Try to kanang familiarize, okay, this chart. Now let's talk about the equations for the energy used. Energy used, okay. Let's focus our topic on the companies that is doing the or the source of our energy. So utility companies sell energy consumptions. Okay, that is what we are using and utilizing every now and then. Any power one can generate on one's own is a money saved. So We actually calculate the amount of energy or electricity at home by using this formula. We have energy is equals to the power divided by the time. Again, the involvement of time here is for us to know the actual consumptions of energy or electricity that we that every machine or every individual is using every now and then. Okay? Basically, pwede siya in hour, pwede siya in a day, pwede siya in a week, pwede siya in a month, or for the whole year, or throughout the generation. Okay? It's the same thing. To determine the energy consumed, multiply the watts time hours of the operation. So I gave you last time a problem set that actually kuwan siya, nag-focus siya sa year. And most of your answers there, wala niyo gi-convert no ang year into seconds. Okay? Or wala niyo gi-convert into hour. You have to make sure man good class nga kuwan, in every kanang given gani nga mga situation, especially sa problem set, if we have this certain amount of electricity or power to calculate, you have to remember that you are not calculating the power as a year. Okay, you are calculating the power or electricity as an hour. Okay, every hour yun na siya. Hindi siya pwedeng a year because kung mag-calculate ka as a year, it's the same thing. You have to do some conversions. No, you have to convert the year into month, and then you know simplifying the situation. Then after simplifying the situation, you can actually just get the unit that we're looking for, the kilowatt per hour, okay, or the watts per hour, okay, because that is the unit for the energy consumption. Okay, for example, we have here a sample situation. A lighting fixture is is drawing 0.71 ampere with 120 volts applied. If the light is lit for 4 hours, how much energy is used? So by using the formula to calculate, okay, the energy used or the energy consumption, we have power is equals to the volt times the current or the I. And then we substitute the given values, okay, to this formula. So we have 0.71 ampere and then times the 120 volts. Okay, so ampere for the current, volts for the voltage. So just multiply the two and you'll get 85.2 watts. But remember, we are looking for the energy used in this specific situation. Okay, we're talking about the lighting fixture. Okay, so there's an object involved. So to calculate the energy consumption, we use the energy is equals to the power times the time. Okay, now we have uh, we have our formula here. So all we need to do is to substitute the given values. We have our calculated power, which is 85.2 watts. Just substitute that one times our given time. We have 4 hours. So you don't have to convert this hour into seconds or minutes. Okay, because we're talking about a kilowatt hour man po. So our answer will be after multiplying the two, you'll get the product of 340.8 watts per hour. Or actually, pwede siya may mukha no, 0.3408 kilowatts per hour. Pwede na to siya ginaon pagkuha. Okay, this is what I meant kanina. There are conversions involved when it comes to calculating. So there are necessary conversions that one needs to know in electrical production. Like for example, again, we have to stick on the unit itself, kilowatt per hour or megawatts per hour. So how do we do that? So we have here a sample conversion of no of some of the given. Okay? Kung kabalo bitaw mo sa mga prefixes class, actually makuha nato na siya diretso no. Like for example, if you know the value of each prefixes. So if we have here kilowatts, so automatically pag kilo ka, di ba? It's triple zero. If we talk about megawatts, automatically if the word mega, okay, we have six zeros. So for us to understand that symbols, ato na siyang ato na siyang i-elaborate. So 1,000 watts for what for an hour and 1,000,000 watts used for an hour. So to convert watts to kilowatts, divide by 1,000. So try kwan, to understand this given problem. Like We have example as well. If a circuit uses an 11,500 watts per hour of energy, a power company will charge the following. So how many kilowatts? Simple. All you have to do is to divide that 11,500 watts per hour to 1,000 to make it 11.5 kilowatts per hour. So understandable na ba ang conversions? And
Yes.
okay. So
Yes, sir.
calculating the Ohm's law depends again on the what do you call this one, on the formulas. So we have different formulas there. All you have to do just familiarize. Abala mo siguro bagkuha siguro because try to understand the situation man good and then use the perfect formula for that one to get the answer. Okay, this is what I meant ganina class about learning the prefixes. So we have prefixes of tera. Okay, it's not tetra, it's terabyte. Good, di ba? Sometimes mong good is kakwanta, nakasayot na. Tetrabyte, yung sa mas tetrabyte. Uy, asa mo lagi kasi tetrabyte? So actually it's terabyte. Terabyte is okay, terabyte has a symbol of T and it has a value of 1 trillion. How many zeros can you see sa trillion? We have 12. Okay? If tera ka, we have 12 zeros. If giga ka, we have 9 zeros. If mega, 6 zeros. If kilo, naatay 3 zeros. Ang milli is naa siya'y 3 decimal, okay, after the point. So we have 1,000. So padali na siya. The opposite of the mega is the micro. So we have 1 million. So we have 6 zeros in the opposed direction. The nano is the opposite of the giga. We have also 9 zeros opposite to the giga. And for the pico, we have trillion, the opposite of the tera. So just kung lang siguro. Uh, familiarize this one. Okay. So another samples for conversions. Okay. If we will be looking for 1,000 of watts into kilowatts, just have to divide it 1,000 to 1,000. And then if you're looking for the shortcut or the prefix of the 1,005, 1,500,000 watts, we have 1.5 megawatts. Okay. And then if we're looking for a short version for the mega ampere, if we have 0.0032 ampere, just divide it to 1,000 again, then we'll have a 3.2, which is a small letter M represents for milliampere. Okay. And then we also have here 0.00004 ampere to cut it short, since we have a reverse an opposite zeros here, so ato siyang i-divide sa kwan. Ato siyang i-divide sa 1 million. Okay? For us to get the 40 microamperes. Okay? So the conversions of the units depends on the given values. Okay? Okay. Let's talk about series circuits, since we keep on talking about where the current flows or how the current flows. So one font for current to flow is what we call a series circuit. The best example for the series circuit class is the let's say Christmas lights. Okay, so Christmas lights pag gusto na siya ka-wire, no? But we have this multiple number of bulbs. But you have to understand that the source of those of the power of the current that is flowing to lighten the bulbs are coming from one major source lang, okay, specific source lang. So pasabot ba na sa circuit, if you have example power supply of battery, di ba? So the battery here is a voltage, okay? We represent it as a voltage. So what's with the series circuit, the I? We have total resistance is equal to the sum of the individual resistance. Okay, try to look at these laws that govern the series circuits. So we have here the resistance. Okay, so for the resistance, we have to add see R1 plus R2 plus R3 plus so on and so forth. Okay, that is the purpose of the for us to understand the series circuit. Okay, and then we also have here the voltage. Okay, the voltage at the same time is the equal to the sum of the individual voltage drops. Of course, no? As the voltage, as kung ang voltage ang source mismo sa current, syempre, the source or the current were, I'm sorry, the current kung asa nagwa siya ka ng source na voltage will have to stop in every bulb, for example. Okay? Para masiga ang every bulb, no? So, that's why we have to add all of the the voltage that is actually dropping per ano per uh, for example per bulb, and the current is the same throughout the circuit. So ang current is infinity siya dani, okay, regardless kung magsugod siya sa negative then mabalik siya pagka positive and so on and so forth. Okay, so this is the sample figure for the series circuit. Okay, so again uh, R1 plus R2 plus R3 plus R4 is for the total resistance equal for the individual resistances. And then for the voltage source, again, in every resistance, there is voltage. It's the point of having the current. And for the current, isa lang siya for infinity. Okay? Isa lang yung dagat. Okay? Isa lang yung path. How about the parallel? The parallel is the opposite of the series circuit class. Okay? For the parallel circuit, the voltage is the same throughout the circuit. Okay? So, same source. And then the current is the sum of the individual circuits. So, for the resistance, the total resistance is always less than the smallest resistance. So, try to look at this picture. Okay? This picture will tell us that there are also laws that govern the parallel circuits. Since we're talking about the current that is the sum of every individual circuits where the resistance is the reason why they are divided into many division. So we have to understand that change na-change sa iyahang sa iyahang formula. So we have here, okay, for the resistance, we have since the resistance or the resistances are divided into many, so we have RT is equals to the one here is pwede gyapon nato siya equal class nga 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus 1 divided by R4. So na naman tayo divide sir. Kaning 1 dani sa iyahang kanang sa taas, no? Okay? Sa bukat sa sayang numerator. Kani sa sayang numerator dani class, the this should be the only wire supposedly. For example, no, this is the only source dapat. But then, since we have resistances in every division, we need to consider as well the the presence of the resistance. So we have one is divided to the division of those following resistance. That's why we have one is divided by one divided by R1 plus one divided by R2 and so on and so forth. For the voltage, since we only have one source of voltage, we have V1 is equals to V2 is equals to V3 and so on and so forth. Okay, as many as it can. Okay, kung makaya, no? Next will be the current. So, sa current, kung ato siyang i-compare din sa atong series, it's the opposite of our uh, voltage, no? Because in our voltage here, sa atong voltage man ko dani is we tend to summarize. Okay, we tend to get the summative number of voltage in one current or in one single path. But here sa ato ang parallel, naatay it's siya ang ato ang current dani is divided siya. Okay? So, i-total nato ang per current niya in every voltage. Okay? Because in every resistance, there is a current. Okay? Okay, again, the function of the resistance is either to allow or to prevent the current to flow. So, there will be a change of rotation kung nanay resistance hanggang. That's the reason why mangyayang current is atin siyang kuhaan summation. Okay, if there's the same resistance in parallel, the resistance can be divided by the amount of times used. For example, no, we have R1 plus R2 plus R3 is equals to 10 ohms. So automatically, for us to get, no, the, the, let's say, the quotient of every, okay, of every resistance, we divide this 10 ohms to 3, since there are three resistance that is, let's say, present in this problem. So we have 10 divided by 3, so we have 3.3 ohms. Okay? Okay, another also for the parallel circuit is if there is a different resistance in the parallel, it can be grouped. Okay? So pwede siya mag-group daw according sa current. So how do we group this one? So if we have the R1 and R2 here, for R1 we have 50 ohms, for the R2 we have 75 ohms. And then we need to get the current, no? Or we're trying to calculate the total resistance of one of this given situation. So for us to get the total ohms of this two sample resistance, we have 50 for the 50 ohms. Okay, so times 75 divided by 50 plus 25. So we have an answer of 30 ohms. So how did we get the 30 ohms? Okay, giunsam na siya pagkuha ang 30 ohms ti ay. Try to calculate daw class if we get the 30 ohms jud exact. No may calculator di sa inyo ah. Try to justify the answer of this one daw ko no. If are we really getting the 30 ohms? Okay, let's try to skip this concept for a moment. Okay? Mag-open cam na ako siguro sa kuha next discussion nato para masabtan nato ni siya. Okay, actually, if we get the different resistance in the parallel, we have to look for the LCD ba na siya ang tawag na the last common denominator, okay, of this one. Like for example, no, usay last common denominator for the 50, usay last common denominator for 75. So, process no to get the answer. So let's try to skip this one for a while also. Okay, how about if we will be combining the series and the parallel circuits? Okay, so if we combine the both series and parallel configurations, so there are steps that you need to remember. Okay, so it involves different steps for us to understand how to solve for the series and parallel circuits. We have to determine the different series and the parallel parts. So how do we identify or determine those different series and parts of the parallel as well? For example, in this figure, no, if we have this single path of what uh, of a current, okay, and we have only one source of voltage, automatically we can actually say that if we remove this part, panibitaw na yung si R2 dani o si R3, if we remove this part, pwede natin na siya matawag na series na. But the next step that you will do is you have to break down the parallel circuits to a single resistance. So how do we break down those parallel circuits into a single resistance? You need to solve first for the R2 and the R3. Di ba? You have to solve for the R2 and the R3. You have to get the answer, the total resistance of the two. Ngano ko ano siya ang total resistance of the two? Para may mo na siyang series, may mo na siyang series na circuit. Okay? And then, we draw the circuit as a series circuit. If we will be drawing this figure, the illustration will now be, uh, let's say that the source of the current is coming from the R4. So from R4, it will travel through, after calculating the R2 and the R3, may muna siyang R23. Okay? And the current here will be now turned into 2. Okay? Ano naman, isa naman ka current line ang flow line sa ilang duha once na ato na siya makumbine. And then, flow na din siya sa R1. Okay? Para may mo na siyang series ng circuit. And then you calculate the total resistance. Okay? That includes the total resistance of the R2 and R3 from the parallel circuit. And then calculate the current and voltage is known. Okay? Since our voltage here is known, so you can actually calculate no the total resistance. And then calculate also the voltage if the current is known. So if there's no voltage given, then you can actually just calculate the current no by the given resistance. Either they've been calculated already by combining the resistance from the parallel circuit. Okay, let's try to go back in this problem. So let's try to see if we can get this 30 ohms, okay, based from the calculation. So for a while lang sana siya. Okay. Let's try to find out ano. Okay. So, I have a question sa inyo. Okay. Unsay kay last common denominator nga to pwede magamit nga pwede siya sa 50, pwede po siya sa 25. Ay, electricity nila? 5. 10 over 10 tapos hindi siya is 14. I don't know, dili. Hello class apa ni class? Okay. Na mo idea say last common denominator taning sa 50 and 75? Ha?
5, sir.
5.
Oo, 5.
5, no?
5.
So if we have let's try to correct this one. Okay? Kay marag diskumpiyado ko sa answer sa kwan. So if we have let's try to see no kung 5 ang iyang last common denominator between 50 and 75. So probably ang iyang kwan na is we have 10 and then 75 divided by 5. We have 10 and 15. No? Then let's try to kwan. Okay? Ako na lang i-present sa inyo class this kanang parallel circuits next time. Okay? Mag-open cam ta. Okay? Let's try to kwan to see kung say kwan na dani. Okay? I was trying to kwan mo good. Not to show you my kwan. Ito na ko sa inyo ha. Okay? We're trying to look for this one no. I'm sorry. Tell me kung same taog kwan, same taog ka nang gibuhat karon. Hello, are you still there? Sige, wait
Yes,
lang class.
sir.
Nag-lag
Yes,
class.
sir.
Sa photo na ko sa laptop, nag-ibong lag. Okay, ako lang pansin nyo. Kung ako mo ko siyang i-1 divided by 50 plus 1 divided by 75, you will get an answer of 0.30. Diba? Try nyo gani. So, it's 1 over 30. And then, kung ato na siyang ibali, pwede siya may mong 30 divided by 1. Okay? But later, well, siguro next meeting, siguro na ato na siyang tanawon. Okay? Let's try to come up with a proper solution. How come we have this 30 ohms, okay, out of the 50 and 75? If the LCD that we need is 5, then how come nakapatag 30, no? Is it 5 times 6, 30? No, hindi mo siguro, no? Or 2 times 3. Anyways, let's deal this one siguro next time. Bakit ano pang screen sa inyo dyan, class?
Yes, sir.
Wait lang kay nakuha na po siya. Okay, I'm sorry. Okay, if there's no question, uh, let's go on. Again, let's deal with this solution next Wednesday siguro. Okay, let's try this kaning process, no? Kaning process. Makita ko nilya, nalawit
Yes,
sa
sir.
board. Uh, let's try to deal this one because if we have this solution manggod, we can actually get the 0.30. But we're not looking for the 0.30, no? We're looking for the 30 ohms. So let's try to find out kung saan nato pagkuha na ang 30 ohms. Okay? So if there's no more question, thank you so much for listening. Let's see if we can answer this 30. Okay? Or at least I can give you some of the ones, some example siguro on the series and the parallel circuit. Okay? Okay, that's it everyone. See you this Wednesday. Bye.
Bye, sir. Bye.
Goodbye,
Thank
sir.
you,
Bye,
sir.
sir.
Bye,
Bye.
sir.
Bye,
Thank you.
sir.
Goodbye. Goodbye.